video, we're going to wrap up section 7.4, those sum and difference formulas, and we're going to start off by sort of reversing what we did in part 1. So here in example 4, we're asked to find the exact value of this. Sine of 42 degrees times the cos of 12 minus the cos of 42 times the sine of 12. And we're looking for patterns here. And when we boil it down, we have sine cos minus cos sine. Sine times cos minus cos times sine. Does that fit one of our sum and difference formulas? Well, here they are. Sine cos minus cos sine. Well, here's sine cos plus cosine, and here is sine cos minus cos sine. So that tells us we're using the sine of a sum. So we can take all of this and break it down to the sine of the first time minus the second. The sine of the first thing minus the second thing. If you want to think in u's and v's, u is 42, v is 12. u is 42, v is 12. So here, this is just the sine of the first thing is u, 42 degrees, minus the cos of 12, or the 12 is the v, so 12 degrees. Sine of 42 minus 12 is 30, and the sine of 30 degrees, we know from the unit circle, is 1/2. So this is an exercise in pattern recognition. Take what you're given, fit it into one of these formats from our sum and difference formulas, and then simplify. Here in example 5, it says this shows how to use the difference formula to prove a cofunction identity. Here's a cofunction identity. You've seen this on your formula sheet. The cos of a half pi minus x is equal to sine x. Cofunctions of complementary angles are equals. These are cofunctions, sine and its cosine. A half pi minus an angle and an angle are complements. Complements, yes. So we're going to prove that this is true. And what we have is the cos of a difference. The cos of a first thing, a u, minus the second thing, v. And we can use our formula to work this out. So the cos of a difference is the cos of the first thing, half pi, times the cos of the second thing, x, plus the sine of the first thing, half pi, times the sine of the second thing, x. And still, we don't know what x is, but we can go to the unit circle for these half pi's. The cosine of a half pi is 0, and we're multiplying that by cos x. And then plus, the sine of a half pi is 1 times sine of x, whatever that is. Now here in the first term, 0 times anything is 0, so that's gone. And then we have 1 times something, and that's equal to our sine x. So yes, this left part here is equal to sine x. We just showed that. When I see down in the corner a historical note, I can't remember what that is. Hipparchus, considered the most eminent of Greek astronomers, was born in 190 BC in Nicaea, I think it's pronounced. He was credited with the invention of trig. So this is the guy you can blame for all the torture I've been putting you through this school year. He also derived these sum and difference formulas. Sine of a sum or a difference and cos of a sum or a difference. So these formulas have been around for well over 2,000 years. Students in classrooms for millennia have been learning about these sum and difference formulas. I am more than happy to pass them on to you. So, sum and difference formulas can be used to rewrite expressions, such as the sine of theta plus n pi over 2 and cos of theta plus n pi over 2, where n is some integer, as expressions only involving sine or cosine. The resulting formulas are called reduction formulas. These are also on your formula sheet, and we can also derive them like our forefathers did so long ago. So here is the cos of theta minus 3/2 pi. It's the cos of a difference. This fits the pattern of cosine of u minus v. Well, if we break that down with our formulas, that is the cos of the first thing, theta, times the cos of the second, times the cos of 3/2 pi. And then we add the sine of the first thing, theta, times the sine of the second thing, 3/2 pi. And now we can go to the unit circle for the ones that we do have the angle value. The cos of theta stays the cos of theta. We don't know what theta is. But the cos of 3/2 pi, cos is an x value that lands right on the y-axis, so that value is 0. Plus sine of theta, we don't know what that is. And the sine of 3/2 pi is on the y-axis, on the negative side, -1. So 0 times anything is 0, that is gone. -1 times sine is negative sine of theta. Part B, we're going to finally use that tangent formula. So tangent of theta plus 3 pi. That tangent of theta plus 3 pi. If we go to the formula sheet and look at the tangent of a sum formula, we can start plugging some stuff in. And we start with our numerator. That is the tangent of the first thing plus the tangent of the second thing. And then we work on our denominator. The denominator is 1 minus these two numerator terms multiplied, the tan of theta times the tan of 3 pi. And again, for the things we know the value of, we can go to the unit circle. Tan of theta, we don't know what that is yet, so tan of theta. The tangent of 3 pi, that is going to be equal to 0. In our denominator, 1 minus tan theta, whatever that is, times tan of 3 pi, and that's times 0 then. So in the numerator, tan of theta plus 0 is tan theta. In the denominator, anything times 0 is gone, so we have 1 minus 0, or just 1. Tan of theta divided by 1 is just tan of theta. That's it for the examples. Here's some practice problems. Pause the video, try them out, and then check your answers. So let's see here in the first one, we see cos, cos, minus sine, sine. Because it's cos, cos, sine, sine, I know right away that it's going to be a cos of a sum or a difference. And because it's subtraction here, it tells me it's going to be the cos of a sum, u plus v. So, the cos of the first thing, our u value is a 16th pi, plus the second thing is 3/16 pi. Our denominator is common, so it's going to be 16. 1 pi plus 3 pi is 4 pi. And we can see that that fraction is reducible to 1/4, or cos of pi over 4, which off the unit circle is root 2 over 2. In the second one here, they're asking us to prove the identity. So we have the sine of a difference, the sine of a difference. And if we go to the formula sheet, that is the sine of the first thing, half pi, times the cos of the second, x, whatever it is, minus the cos of the first, half pi, times the sine of the second thing. On the unit circle, sine of a half pi is 1. 1 times cos x. Minus the cos of a half pi is 0 and times sine x, so that's going to be wiped out. 1 times cos x is cos x, just like we were looking for. And the last one, we're going to simplify the expression, and we see we have the cos of a difference. Cos of a difference, if we go to the formula sheet, that's going to be the cos of the first thing 3/2 pi times the cos of the second plus the sine of the first times the sine of the second. Off to the unit circle, the cos of 3/2 pi is 0 times the cos x, plus the sine of 3/4 pi is going to be -1 times sine of x. So 0 times anything is nothing. Minus 1 times sine is negative sine of x. So we simplified the expression from this down to negative sine x. Homework for this section, page 572, 573. It looks like quite a bit, but the first piece is pretty simple, where you're breaking down a sum or a difference. Problems like this, where you're doing, once you recognize the pattern, you're either going to add or subtract these given u or v values.